Welcome to the deep dive. Today, we're looking at something really fundamental to how we experience the world, our vision.
Hmm.
But, this isn't just about whether you can read the fine print.
No, not at all.
We're going to uncover some surprising ways your eyesight actually impacts your entire well-being,
Mm,
mood, concentration, even like your metabolism.
It's huge, and it really does feel like needing glasses, for nearsightedness or farsightedness is just becoming the norm.
Yeah, almost like we've just accepted it's unchangeable.
Exactly. So we've gathered some really insightful information that gets into the nuts and bolts of how our eyes actually work,
Oh, okay.
and importantly, what we might actually be able to do to support them. It's kind of time to sort out what's genuinely helpful from all the noise out there.
Absolutely. So, our mission in this deep dive is really to understand our visual system better,
Hmm.
explore why certain vision problems seem to be, well, skyrocketing, maybe,
Yeah. That's a good way to put it.
and empower you with some reliable knowledge about, what works and what doesn't for vision improvement.
Right.
And here's something to really chew on. Your vision has this significant direct connection to things like your mood, how well you focus, sleep patterns, even how your body uses energy.
It's pretty wild when you think about it that way.
Okay, let's dive in.
So what's fascinating right off the bat is that just seeing clearly, that's really just the tip of the iceberg.
Okay.
Think about it.
Yeah.
Your eyes are constantly feeding information about the world to your brain.
Right, like nonstop data streaming.
Exactly. And the brain, it's tucked away in your skull, so it relies heavily on all your senses, but especially vision, to make sense of everything happening around you.
It's like our brain's main window to the world.
Precisely.
And it's not just passively receiving this information, is it? It seems like our vision actively shapes other things.
Oh, absolutely. Our vision actively plays a role in shaping so many other aspects of our lives.
So if our vision isn't working optimally, it's like having a really slow, glitchy internet connection for your brain, affecting everything else it tries to do.
That's a great analogy. Yeah. As our sources emphasize, vision directly influences things like concentration, mood, even behavior. It's the sense we depend on most to navigate the world and, frankly, to thrive.
Which makes this next point even more, well, striking. It looks like vision problems, particularly nearsightedness, are just becoming incredibly common. The numbers are quite alarming, aren't they?
They really are. Our sources point out that back in the 1970s, in some countries, maybe less than 25% of people had myopia. That's the difficulty seeing distant objects clearly.
Okay, less than a quarter.
Right. But by the 2000s, this had surged to, get this, 42%.
Wow, that's a huge jump in just a few decades.
It is, but it gets even more dramatic in some places, doesn't it?
Yeah, I saw that. Places like Hong Kong, Singapore, Taiwan, they're reporting something like 80% of young people under 20 with myopia.
80%. That's something that was considered pretty rare not that long ago.
Seriously. So what's going on?
Exactly. This rapid increase really begs the question, what has changed so drastically in our environment? Or could it be something called an epigenetic shift?
Epigenetic. Okay, remind me what that is again.
So it means changes in how your genes work, how they're expressed, but without changing the actual DNA code itself,
Hmm.
often influenced by environmental factors.
Ah, right.
And here's where it gets really interesting. Even if both your parents are nearsighted, it doesn't automatically mean you will be.
Oh.
Yeah, the hopeful message here is that while genetics definitely play a role, our environment and how we actually use our eyes seem to have a really significant impact.
It's not like predetermined.
Not necessarily.
Yeah.
It suggests that by giving your eyes what they truly need, the right kinds of input, maybe you might actually be able to avoid developing myopia, or at least lessen the severity.
Okay, so it's not purely down to our genes. That's actually really encouraging.
It is.
But to really get this, we need to look a bit closer at how our eyes actually, do their thing.
Let's talk about the retina. It sounds important, but maybe a bit overlooked.
Definitely overlooked. The retina's main job, basically, is to capture the light that enters your eye and then convert it into electrical signals.
Okay.
Signals that your brain then interprets as the images we see. But, and this is key, the impact goes way beyond just sight.
Yeah, so.
Well, as our sources explain, things like your balance, your mood, your attention span, your overall brain activity, even your sleep-wake cycle,
Mhm.
they're all influenced by what's happening in your retina.
Wow. It's almost the opposite of the screens we spend so much time staring at, isn't it? Like we're glued to devices that emit light.
That's a great way to put it, yes. Your retina captures light whereas screens actively emit it, usually using tiny red, green, and blue LEDs.
Right.
Your retina itself is incredibly complex, layers upon layers of cells, but two really key players for vision are the cones and the rods.
Okay, cones and rods. Tell us about these essential cells. What do they actually do? Well, you have way more rods than cones, but the rods give you sort of lower res vision. They're mostly in the peripheral parts of your retina,
Okay.
and they are incredibly sensitive to light. So that makes them crucial for seeing in dim conditions, helping you distinguish contrasts, light and shadow, but not really color. Think of rods as helping you navigate when it's dark,
Got it. Night vision specialists.
pretty much.
Ugh.
Cones, on the other hand, come in three types. Each one is sensitive to a different part of the light spectrum, red, green, or blue light waves.
Ah, so that's color vision.
Exactly. They handle your color vision and also your sharp, detailed visual acuity. They're packed into the macula, that central part of the retina where your vision is clearest. So cones give you the vibrant details and good light.
And they both need vitamin A, right? You mentioned that was crucial.
Absolutely crucial. For all this light capture and conversion to happen, we need special proteins called opsins. And here's a key insight. All opsins are based on vitamin A.
Okay, wow.
It really highlights how vital vitamin A is for just basic visual function. Now, there are different kinds of these opsins, each with a specific job. One particularly interesting one is called melanopsin.
Melanopsin. That sounds important. What's its main gig?
Melanopsin is found in certain light-sensitive cells, particularly in the lower part of your retina, and it's a master regulator of your sleep-wake cycle, your circadian rhythm.
Okay, the body clock.
Right. But here's the interesting thing. It's not so much about the color of the light, like we often hear about blue light. It's more about the total amount of light, the overall brightness hitting these cells.
So quantity over quality, in a way.
For this specific function, yes.
Yeah.
More light signals to your brain, hey, it's daytime. Less light signal, okay, time to wind down for sleep.
Ah.
In fact, the lack of melanopsin stimulation is why you tend to sleep longer if you're in complete darkness.
That makes total sense.
So the big takeaway here is that light isn't just for seeing. It's directly controlling our sleep patterns and maybe even our hunger cues.
So it's like our internal light meter, constantly adjusting our body's clock.
Precisely. And melanopsin also plays a role in controlling the size of your pupils, how much light gets in.
Right.
But what's truly fascinating is that these melanopsin-containing cells, which seem pretty simple, regulate a surprising number of things. Your daily rhythms, your metabolism when you feel hungry, even your level of motivation.
Motivation, really?
Yeah, think about it. Naturally, your motivation tends to dip at night, right? That's partly melanopsin's influence. It's also a key player in what's called metabolic jet lag.
Metabolic jet lag. Like from traveling.
Exactly. But it can also affect shift workers, anyone with really irregular schedules. It messes with your body's energy use and timing.
Wow, that's a much wider reach than just telling us when to feel sleepy.
It really is. And our sources point out something cool. Even in really early organisms, like way before complex eyes evolved, they still had this ability to sense day and night and the type of light. And this basic light sensing impacted their biological activity, hormones, cognition, energy levels, even reproduction. It was like a fundamental internal timer built in from the start.
That's amazing. Okay, what about rhodopsin? That was another one you mentioned.
Rhodopsin, that's the main protein used by the rod cells. So it's primarily for that lower quality vision you get in low light. It's all about distinguishing contrast shades of gray rather than fine details or color.
Okay, the workhorse for dim light.
Exactly. Then when we switch to the cones for daytime vision, the different opsins they use are essential, not just for seeing color, but also for regulating our nervous system and the rest of our body.
And this is where the blue light discussion fits in.
This is where it fits in more directly, yes. The cones, sensitive to short wavelength blue light, can affect your circadian rhythm. That's why limiting too much artificial blue light in the evening is generally good advice.
Right, the sleep disruption thing.
Yeah. But, and this is important, activating these cones with blue light during the day is actually crucial for good vision and for keeping your internal systems properly tuned.
Okay, so blue light isn't inherently bad. It's about timing and maybe intensity.
Precisely. This all really underscores why getting full spectrum light, especially morning sunlight, seems to be so beneficial. It's not just about seeing clearly in the moment. It's about tuning your entire biological system for the day.
Yeah, makes perfect sense.
Exactly. Okay, so shifting gears a little bit, let's talk about vision exercises.
Ah, yes, this comes up a lot.
It does. There are tons of claims out there. So we understand a bit more about how our eyes work now and why problems like myopia might be increasing.
Right.
So let's look at what we can actually do about it, starting with these vision exercises.
Yeah. Because you see all kinds of programs, apps, even supplements promising like miracle cures for bad eyesight. It's really hard to know what's legit.
It is. And our sources acknowledge the appeal, for sure. But it's really important to be cautious about claims of radical improvement, especially just from popping pills.
Yeah.
However, the idea of exercising your vision,
Mm.
it does have some merit, just maybe not in the ways people often think.
Mm.
We need to separate, like, temporary improvements, which might just be from better blood flow or relaxing eye muscles for a bit, from actual long-term changes in how well you see your visual acuity.
Okay, good distinction. So let's break down some common types. What about those exercises where you like roll your eyes around, look up, down, side to side?
Right. Those exercises primarily target your extraocular muscles.
Hmm.
Think of them as the tiny motors that move your eyeballs around in their sockets.
Okay.
Doing those can be beneficial for things like your balance and even your posture because eye position is linked to that,
Oh, interesting.
but they're likely to have very little, if any, impact on your actual visual sharpness, your acuity.
So they won't make you need weaker glasses.
Probably not. The old theory behind some of those was that maybe tight eye muscles could somehow squeeze the eyeball and make it longer, causing myopia.
Right, I think I've heard that.
Yeah, but it's considered highly improbable. The evidence just doesn't really support it. These muscles, while important for movement, just aren't strong enough to permanently change the shape of your eye like that.
Okay, so eye rolling won't cure my nearsightedness. Got it. What about accommodation exercises? Focusing exercises?
Now these are different. These relate to the lens inside your eye, the crystalline lens.
The one that changes shape.
Exactly. Unlike the fixed lens in your glasses, this one is flexible. Tiny muscles around it, the ciliary muscles, make it contract or relax to change its shape.
Right.
It bulges or contracts to help you focus on things up close, and it flattens or relaxes to see things far away.
Okay.
Now, as we get older, this lens naturally loses some of its flexibility. It gets harder to make it bulge enough to focus on near objects. That's presbyopia.
Ah, so that's why many people start needing reading glasses in their 40s or 50s.
Exactly. And this is where accommodation exercises can genuinely be helpful.
Oh, how so?
By specifically targeting and working those ciliary muscles that control the lens shape, these exercises can actually improve presbyopia, or at least slow its progression.
Really?
Yes. They typically involve consciously shifting your focus between objects at different distances, near, far, intermediate. It's like physical therapy for your focusing muscles.
So, if you're starting to struggle reading your phone menu, these kinds of exercises might actually make a noticeable difference.
They very well could, yes, according to our sources.
Okay, that's good to know. Now, what about using these accommodation exercises for myopia, for nearsightedness? Does that work?
That's the million-dollar question, isn't it? Because myopia is difficulty seeing far away.
Right, which involves a relaxed lens and ciliary muscle.
Correct. So exercising the focusing muscle doesn't immediately seem like the solution. Historically, the idea linking near work to myopia was that maybe all that prolonged close-up focusing caused the eye to adapt by actually growing longer.
Ah, the eye reshaping itself theory again.
Sort of, yeah.
Yeah.
As a compensation, so it wouldn't have to work so hard to focus up close all the time. Now, while accommodation exercises probably won't reverse existing myopia like, they won't make your eyeball shorter again.
Okay.
They can apparently be beneficial, especially for kids, in potentially slowing down how quickly myopia gets worse.
So, slowing the progression in children.
That seems to be where the evidence is strongest.
Okay.
And they can also just provide a feeling of relaxation for the eyes, which might feel strained from near work.
Okay, so not a cure for nearsightedness, but maybe helpful for managing it, particularly in younger people.
That seems to be the gist. It's important to remember, accommodation is primarily about focusing near and intermediate. But here's another key insight from the sources.
Okay.
While we might not easily change the physical length of the eyeball, the brain's interpretation of the visual signals can be modified.
Ah, neuroplasticity again.
Exactly. If your brain gets constantly adapted to only processing sharp images from near objects, its ability to interpret distant objects clearly can actually decrease.
Even if the eye could technically focus the light properly?
Potentially, yes, or at least the perceived clarity suffers. It's like the brain gets lazy or out of practice with distant details. This isn't necessarily because the eye shape changed further, but because the processing isn't optimized for distance anymore.
So it's more about training our brain's visual software than fixing the eye's hardware.
That's a really good way to think about it. Yes. And training your brain to actively focus at a distance can improve this perceived clarity. It might even help prevent some vision-related headaches people get.
Okay, and how do you do that? Is it complicated?
Surprisingly simple, actually. It just involves consciously and regularly taking moments to focus on objects that are increasingly further away. Look out the window, focus on a tree, then a building further away, then something on the horizon.
Actively paying attention to distant things.
Basically, yes, giving your brain that distant input to work with regularly.
That sounds like something we could all probably do more of, especially with how much time we spend glued to screens right in front of our faces.
Definitely. Now, there was also mention of exercises for a lazy eye. Are those effective?
Amblyopia, right?
Yes, amblyopia. And on this, our sources are pretty clear. Exercises for lazy eye are strongly supported as being effective.
Okay, good news there.
Yeah. Most people naturally have a dominant eye, one that has slightly better sharpness, or maybe a wider field of view than the other.
I think I know which one is mine.
Most people do if they think about it. And this difference is significant even if you don't have a clinically diagnosed lazy eye.
How so?
Well, it can influence things like your head posture. You might subtly tilt your head to favor the dominant eye. It could affect your balance and even cause muscle strain around the eyes or neck.
Never thought about the posture link.
Yeah, if you heavily rely on one eye, it can lead to these subtle imbalances and sometimes even difficulties with tasks like reading smoothly. So training the weaker, non-dominant eye has a really positive impact. It boosts neuroplasticity, the brain's ability to adapt and rewire.
Right.
And it can improve posture and just make your overall visual system work more efficiently and comfortably. Remember how visual info crosses over in the brain?
Vaguely. The stuff from the nose side of the retina goes to the opposite hemisphere.
Exactly, from the nasal retina.
Yeah.
By consistently favoring one eye, you're not fully utilizing that cross-processing pathway for the other eye.
Okay, so how do you actually exercise a lazy eye? Or even just, balance things out better between the two eyes if you don't have a major issue?
The method is actually quite straightforward, often involving patching. You simply cover your stronger eye for a set period each day.
Like with an eye patch.
Yeah, exactly. Maybe for 5, 10, or more minutes. The exact time depends on the situation and professional advice, of course. And you do this while you're doing visually demanded tasks like reading or even just looking at distant objects.
And that forces the weaker eye to step up?
Precisely. It forces the weaker eye and its connection to the brain to do more work, strengthening that pathway. It sounds simple, but it can be very effective.
That does sound surprisingly easy, yet potentially really impactful. Okay, let's move on to something else that seems to have a big effect, especially with kids and myopia, just spending time outdoors.
Yes, this is a really compelling area of research. Our sources highlighted a fascinating example from Taiwan.
Oh, yeah. What did they do?
Well, faced with skyrocketing myopia rates in kids, the government there actually implemented a program requiring schools to ensure students got at least 2 hours of outdoor time every day.
2 hours mandatory outdoor time.
Wow. Yeah. Integrated into the school day.
And did it work? Did it make a difference?
The results were really encouraging. Now, it wasn't like it instantly reversed everything, but it did demonstrably slow down the rate at which kids were needing new or stronger glasses. The upward trend started to flatten.
That's significant, just from being outside more.
It really is. And it's particularly striking when you consider the context. Children today, on average, spend less than half the amount of time outdoors compared to their parents' generation.
Wow, less than half.
And their parents probably spent less time outdoors than their grandparents. So there's been this dramatic generational shift indoors.
That's a stark difference. Really paints a picture of how our daily lives have changed.
Exactly. And it strongly suggests that even more time outdoors would likely lead to even greater benefits for vision.
So why does it work? Is it just about not looking at screens?
That's likely part of it. The reasons are probably twofold, maybe more. First, when you're outside, you naturally spend less time focusing intensely on very close objects, like a phone or a book.
Right.
Your gaze is naturally drawn to more distant things, panoramas, things further away. It gives those close focusing muscles a break.
Okay, changes the focus demands.
And second, it's about the light itself. Outdoor light is much brighter and has a broader spectrum than typical indoor lighting. This intense, full-spectrum light stimulates the retina in ways that indoor light just doesn't.
Ah, stimulating those retinal cells we talked about, like the ones with melanopsin.
Exactly, and probably others too. It seems to provide important signals for healthy eye development and function.
So it's a combo of the focus distance and the light quality and quantity.
That seems to be the leading hypothesis.
Yeah.
So our sources really advocate for finding ways to incorporate more outdoor time, even if you're using screens.
Like taking your laptop outside to work.
Yeah, or listening to this deep dive while sitting on a park bench. It's about maximizing your exposure to that natural light. They even suggest maybe avoiding sunglasses when they aren't strictly necessary for glare or UV protection,
Oh, why is that?
to ensure your retina gets that full, robust stimulation from the ambient light. Simple things, using your devices outside sometimes, encouraging kids to play outdoors more. It could make a real difference.
It really sounds like a pretty simple and, frankly, enjoyable way to support healthy vision.
It really does seem that way. Less complex than trying to remember eye exercises, maybe.
Huh, maybe so. Well, let's try and bring this all together. We've certainly covered a lot of ground on the fascinating world of vision today.
We definitely have. And I think the key takeaways are pretty clear. First, vision is just this incredibly powerful sense influencing way more than just our ability to see clearly: mood, sleep, metabolism, the works.
Right, that connection is huge.
Second, that concerning rise in myopia really strongly suggests that environmental factors, how we live, how we use our eyes, are heavily at play. It's not just genes.
Okay.
Then, regarding exercises, some, like the eye-rolling ones, probably have limited impact on sharpness itself. But accommodation exercises can be genuinely beneficial for age-related focus issues, presbyopia.
And the lazy eye exercises.
Those are indeed very effective, well supported by evidence. Worth doing if needed.
Good to know.
And perhaps one of the most significant, actionable points is that just spending more time outdoors seems to be a really crucial factor in potentially mitigating the development and progression of myopia, especially in kids.
Yeah, that outdoor time seems key. For me, the real aha moment is understanding just how critical the brain's role is in interpreting everything we see, and just how profoundly light exposure, the type and amount of light, impacts our overall well-being way beyond just eyesight itself.
Absolutely. Which leads to a final thought, maybe something provocative for listeners to consider.
Okay.
Given this profound influence of light and our daily focus habits on both our vision and our broader health,
Right.
what small, realistic changes could you listening right now actually incorporate into your daily routine to prioritize your visual well-being?
That's a good question.
And maybe thinking longer term.
Hmm.
What are the potential consequences of our increasingly indoor, screen-focused lifestyles? How can we become more conscious, more intentional about the visual environment we create for ourselves and our kids?